Okay. Section 3.2, they're calling them extrema and function analysis. It's just a fancy pants words for finding maximums and minimums. So there's a difference though. There's two different types of maximums and minimums. One of them is considered an absolute maximum or minimum. Sometimes they're called global. And they are the highest or lowest point overall when you're looking at the whole graph. Versus relative maximums and minimums, which are also called local maximums and minimums. And that's where a point on the function that's higher or lower than all the points in the immediately surrounding area. So in other words, I say it's in the neighborhood. If you're looking over here at the graph that they gave, and I want to find the highest point overall, the biggest one, the tallest guy, that's going to be this one right here. So he's going to be called the absolute maximum, sometimes called global maximum, absolute maximum. For the most part, we're going to be calling these absolute and relative are the words that we're going to use. But just so you know, if you see it in other books or whatever, that they also can be referred to as global or local. All right, so I'm skating along this graph, skating along the graph. Then I get to this point. Well, he's a low point, right? He's a relative minimum. He's relative because he is lowest in his neighborhood. And then you look at this guy, he is a relative maximum because he is a maximum in his neighborhood, but not the maximum overall. Okay, so finding maximum minimums mean finding the y value. You're looking at what the y values are doing. Maximums, if you think about it, that's a vertical type of thought pattern, right? What's the highest, what's the lowest? So because of that, you're really looking at what the y value is. The x value helps you with the location of the point, but it's not the maximum or minimum value. All right, so here's some things that I put in my margin that you might want to add. Thing number one, and this can be a little confusing in this section, is you're pretty much ignoring when they go to infinity or negative infinity. That isn't part of the maximum minimum concept. Because if you're going towards infinity, you can't really tell me what that number is. So you're ignoring positive and negative infinity. That might have come into your mind as you were watching the video. What about, is that really the highest point? Because it really goes to infinity, and you got to be, yeah, you just sort of ignore it. The best thing I can tell you is ignore the positive and negative infinity parts, because they can be kind of confusing. Your absolute maximum minimum, your question is it the highest or lowest point overall? That was my second thought as I was putting in my margin notes. For relative maximums and minimums, is it the highest or lowest point in its neighborhood? That's the question for that. All right, I'm going to come back to my last margin point after we talk about this next picture. If you need me to swing over and keep the margin notes handy for you, let me know if I'm moving too fast. All right, so he came up with these points. He graphed this graph, and then he came up with the local minimum. That's this guy being negative 2.6, negative 41.3. Then this guy here would be a local or relative maximum at 0, 1. And then he came over here, and this would be an absolute minimum. It's the lowest point overall. And so he identified what they were. What is the minimum value for this function? Well, the lowest it goes to overall is this y value of negative 57.7. So that's the y value that you're looking at when you're looking at that, what the minimum actually would be. So he gave you 3 pictures, and he gave you some explanations. This would be the lowest point overall, so it's the absolute minimum. And this guy here, closed circle, in his little neighborhood, he's a high point. So he's going to be a relative max. But if I took the same picture and it's an open circle, I can't make any decisions about what that is because I don't even know what it is, right? It's an open circle. So there are no relative maximums in this, even though it does kind of go up a little bit because of the open circle. But this is still the absolute minimum. It's still the lowest point overall. And then the last one, you've got still the lowest point overall. Actually, no, he called this now a relative minimum. And again, this was a nothing. This guy here's a relative maximum because he is a high point on this whole thing. This gets a little confusing between, why did he change this to relative? Was he not ignoring the infinity? We're going to ignore the infinity as we do these because, again, it's like this kind of gray line in this whole thing. So we're going to ignore the fact that they go to infinity. So I probably would have kept this as being my, this section always kills me because of the controversy of this whole thing. Let's try moving on. Absolutes. If you're considered an absolute maximum or minimum, you're also considered relative. But if you're a relative maximum or minimum, you're not considered to be absolute. So that's my last margin note from the video. If you are the absolute top point or absolute low point, then you are also considered relative. You're considered to be in the neighborhood, a high point or a low point. And Bella, that's a great question. How do you decide what the neighborhood is, right? I would say if you're looking at, it's going to become clearer as we do some of the example problems in just a minute, but you're just looking in the area of where that is. Like, so if I'm looking at the one you see on the screen here, if I'm looking in this little vicinity, not looking at the whole, like not all over the place, I'm just looking at this little vicinity here, I can see that this point here is going to be in its neighborhood, in its little area. He's the high point, so he's a maximum. So you're kind of, instead of looking at the whole big picture, you're kind of narrowing in, zooming in on just that little area right there and answering the question. So that's kind of how the neighborhood goes, but again, as we do some examples, I think it'll be better. All right, I think we're almost done with his, oh no, then he did this big goal thing. I found Desmos to be much more friendly than what he was doing with the video and the calculator, so we're going to do that. Like I said, we'll use Desmos for what we're doing. And he wanted a friendly window. He went to this whole explanation about finding a friendly window. And really, if you've got Desmos, you can zoom in and zoom out pretty easily to find the right window for you to use. So not to worry too much about that. There was a reminder about domain, so I put that in my margin. Domain is when your denominator can't equal 0 and any even root has to be greater than or equal to 0, just like we just did in the last section. And all of these, we're going to graph them to be able to answer these questions. So that's what he did. He graphed this thing. Let me go and see if I can put the whole, oh, I can almost get all of that on there. Good. Okay. I graphed it first. That's what I would always do with these things. So here's the graph down on my bottom right. Okay, so if you put this in Desmos, that's what you get. And I would identify, before I even answer all these questions that they asked me about, I would identify these maximums and minimums with coordinates. So this one's 0.064, 0.996. And then this top point over here is 3.145.04. And then it comes down and hits the x-axis at 40. All right, so then I go to the questions. First one's domain. Well, I'm looking at the equation, and the equation has a root. It doesn't have any denominators, right, like it would have in the last section. But that root has to stay positive, and so the domain is 4 minus x has to be greater than or equal to 0, so x comes out to be less than or equal to 4. Are there any vertical asymptotes? And if there's not a denominator, then there are none. Are there any holes? Again, if you need a denominator to be able to have a hole because things need to cancel, a top and a bottom. So none. Is there an absolute maximum or minimum? All right, well, you're looking at the graph. We're ignoring the infinities, and I'm looking for the highest point. Here it is, right here. So is there an absolute an absolute min, the lowest point overall? Well, the lowest point overall is this guy that's down here at 40. So he's my absolute minimum. If I come up here, I've got local or maximums that are not. And that would be my 2 points that are here. Those are local. In their little hood, that's a low point. But it's not the lowest point overall, but that's a low point. Where is it increasing? It's increasing between these 2 points. You use the x values. Where is it decreasing? From negative infinity to this x value, and from 3.14 to 4. What's it doing on the left? If I go way to the left, my values are going to infinity, and the right-hand behavior doesn't exist because it stops. There is no right-hand behavior. Whew. All right, so that's all of the video notes that he talked about. We are going to look at just a couple problems together. Let me grab my sheet here. The first practice problem, now these are numbered funny. I don't know if you noticed this, but these are now the practice problems, right? Their numbers are over here. They're not all over to the left like they normally would be. So number 1 is here, number 2. It's number 3 that I want to look at first. So number 3, this one they give you the graph. You do not need to go to Desmos to make the graph. All right, so you're going to look at this and you are checking out what the domain would be, what the absolute max or min, the local max or min, and so forth with this. So, but they give you the picture, so we don't need Desmos quite yet. If I'm looking at this, let's identify some places, right? I need to know some coordinates. Now I'm looking at the graph. Some coordinates that would be important to me are the low points and the high points. Well, that would be this coordinate right here. So let's think about what that would be. That's going to be a -4, -6. And another point that's going to be important to me is this low point right up here. That's going to be at 0, 2. So I'm going to identify my points first just to help me out a little bit. Then I'm going to the domain for this. Now, because they gave you the graph, you could go to the equation and figure it out like we were doing in the last section. I can see, I don't know that you remember how to factor a cube, right? That would make this a little tricky. So I'm just going to use the graph itself to be able to talk about the domain. So the graph, if I look at it, these go to infinities. All of these, all those ends go to infinity. So if I'm looking at it from left to right, it starts on the left at -infinity, and it is happy, 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 happy until I get here, because what's happening at -2? If you think about it, at -2, you have a vertical asymptote. It's not shown on the picture, but you can see that this is the line that it hugs. Now let's look at the equation and see if that makes sense. My equation denominator is x squared minus 4. If I take that and set it equal to 0, x squared minus 4 equals 0, x squared equals 4, x equals plus or minus 2. You can see that that makes sense, that that would be one of your asymptotes. Now there's a reason why the plus 2 isn't, and we'll talk about that in a minute. So again, domain, -infinity, and I'm good until I get to -2 because there's a vertical asymptote there. So I'm going to be with parentheses around that. And then I pick up on the other side of -2, so -2 parentheses again. And I'm good until I get to the hole. There's a hole there. And that hole is happening at 2, at 2 and then 2, right? This hole right here. Maybe it's a little higher. This is it's not going to make our life as easy, is it? If I look at the where the hole is, I'm looking at. Let me go back to algebra where it's safe. I'm thinking factoring, and you can help me out here. If I factor a cube, it's x minus 2, and then it's x squared plus 4. X squared plus, is it AB? 2x. I've got to remember my rules. Been a while. And then plus 4. And on the bottom I have an x minus 2 and an x plus 2. Now the reason why I'm hesitating is because I need to put a 2 in to figure out what this coordinate is right here. I need to plug a 2 into my equation here and figure out what that value is going to be. So 2 squared is 4. 4 plus 2 times 2 is 4. So I'm at 8. Now I'm at 12. That would be my numerator. And on the bottom I have an x plus 2. So 2 plus 2 is 4. Gives me a value of 3. All of that tells me that this should be a 2, 3. That should be my coordinates for this open circle. I just went through that really fast, but you can put that into Desmos and be able to calculate that out probably even easier, but I just, instead of flipping there. All right, so I'm still talking domain, holy moly, long talk. Goes -2, and then it's not the whole, it can't touch that, that's at 2. And then it picks up again on the other side of 2 and keeps going to infinity. All of that is considered to be my domain. All right, then we're into absolute maximums and absolute minimums. So I'm looking at this thing and I'm looking at it as the big picture. So do I have a lowest or a highest overall? That's the question, right? And so if I look at this, it does not have a lowest or highest overall. So you're going to say none for that, but it does have for locals. This guy, well, this one hurt first. If I look from left to right, he is a high point in his neighborhood. In this little area, oh no, you can't see me screen. In this little area, he's a high point. So he's going to be considered to be a local maximum. So I have a local max, and that's at, probably it's easiest to put the coordinate. Local max is at -4, -6. But what does that make this coordinate over here that we kind of highlighted? In his little neighborhood, he's going to be a local minimum. See how he's the lowest point in that little area? So he's going to be a local min, and that's at that coordinate 0, 2. And then they're pulling back things that we learned from before. Where is it increasing or decreasing? So if I go left to right from -infinity until this coordinate, now remember for increasing, decreasing, you're using the x values, which makes it a little confusing too. But it is increasing from -infinity to -4. And then it is decreasing from -4 to -2. Then I skip over to the other side of the asymptote. It is decreasing until I get to 0. So from decreasing from -2 to 0, and then increasing. Technically, I guess I should do this in parts, right? Because I've got an open circle in the midst of that. So we're going to say it's increasing from 0 to 2, and then on the other side of 2 to infinity. So 3 parts because of that silly open circle there. Then left-hand behavior, right-hand behavior, back with the limits a little bit. So they wrote the statement out for you. Thankfully, you didn't have to remember that. But it's looking at the left-hand behavior, what's it doing way far to the left? It's going towards -infinity if I were to continue that. So this is a -infinity on the left. If I look way to the right, it's going towards +infinity. And there you have it. So they're adding in this concept of maximums and minimums into stuff that you already learned with domains and such. Questions on number 3? All right, let's take a random question. My random question is red or green? I don't know. Red or green? Attendance question. Toss it in there. Red or green? It was reminding me around Christmas. I'm actually looking, I have a unit circle that is painted on my classroom wall. And it's got a lot of red or green in it. So that's what I looked up and that's what I saw. All right, we have 2 more we're going to try. These are where we need Desmos to be able to help us out. So we are looking at number 5 and number 7 are the 2 that I'd like to try to do with you. And the difference now is that they did not give you the graph. And you can see, if you look at the equation for these, check this guy out. 1/2 the square root of 4 minus x times the absolute value of 2x minus 4 plus 1. Holy guacamole, that is a big equation. So, and I would have no idea what that thing looked like. So we're going to go to Desmos. If you flip over to Desmos, I'm going to share my screen and do the same. And you're going to type that in. Now, I actually put mine in last night, so I'm now sharing my screen showing you what the picture is. I took that 1/2 and put them in as 0.5s just because I like that better. And also the same thing with taking, actually no, this is the next one. Let me fix this a little bit. Absolute values, you have that in the, if you go down to the show keypad on the bottom, it'll bring up the symbols for these, and there's an absolute value right there that you can use. There's also a square root. So you'll find the square root thing and the absolute value thing in that drop down menu of the keyboard. So I'm going to give you a second to make sure that you have the same picture and you can type it in. It's going to be helpful in trying to do some of the other problems. So we're going to try to draw this on our page. All right, I'm going to assume that you have that in there. If I go to my graph, there are some key points that are going to help me to graph this. So I'm going to, you see how Desmos does that? They're pretty nice about giving you coordinates. So I've got a coordinate there that's at 0, 5. So I'm going to toss that on my picture. 1, 2, 3, 4, 5. I've got another coordinate that they give me over here that's important. That's at 2, 1. So at 2, 1, I'm going to have a coordinate. So I'm just plotting these points on my graph. And then I've got another coordinate that if I go to the high place where this hill is, I can see that it's 3.33. So just a little past 3 and 2.09. So I'm going to put that on my graph, 3.33 and 2.09. And then the last point right here is at 4, 1. So if I click that, they don't have a coordinate there, but if I click on that, it pulls one up and it says, okay, you got a value at 4, 1. So I'm going to put that on my graph as well. 2, 3, 4, 1. So that's all of Desmos. I'm going to take you away from that for a minute and go back to our note packet. And so see, hopefully you got the same kind of thing. I labeled up all these coordinates that were from Desmos, and now I'm going to draw my graph. It came down like this, and then went and did a little hill there. So let Desmos be your friend on these to be able to find those coordinates and such. So the domain for this one, my questions are kind of the same. My domain for this one is going to be how far to the left does it go? And if you think about it, it goes to negative infinity, right? So left goes to that's this arm over here that keeps going. And it has no issues, there's no asymptotes or anything, but it stops right here at 4, right? So if I look at it, it stops at 4, And the question is, do I bracket that or do I parenthesis that? And so we could see on the graph, remember when I put up that point on Desmos, it actually touched at 4,1. So I'm going to bracket that up. And then it's looking for, does it have any absolutes? So if I look at this, does it have a highest point overall, like looking at the whole thing, or a lowest point overall? And it actually does. It has a lowest point overall, and the lowest point, it doesn't go any lower than 1. So I have an absolute minimum, because that's the lowest it goes. And I have 2 coordinates that give that to me. I have either 2, 1 or 4, 1. You probably will see on the answer key, here's how I have it written on the answer key, that there's an absolute minimum at y equals 1, because that's what the y value is. That's the lowest value that it goes to. This says the same thing. They're saying exactly the same thing. It's just in a different way of writing it. Does it have any local maximums or minimums? So if I'm looking in the neighborhood, are there any hills or valleys that I haven't accounted for? And if I look at that, I do have in this little neighborhood, this point right here is going to be my maximum. In its neighborhood, it's got a little hill. So he's going to be a local max. I have a local max. And that coordinate is 3.33 and 2.09. And then we're increasing, decreasing, which we know from before. The first thing it does is decreases. So it decreases from negative infinity until I get to 2. And then it increases up the hill from 2 to 3.33. And then I come down the hill from 3.33 to 4. So there's my increasing, decreasings. What's it doing far on the left? Far on the left. Keep going left. It's getting higher and higher and higher. It goes to infinity. And what is it doing far to the right over here? It stops. It's not doing anything. It doesn't go to infinity. So this one's going to be it does not exist. All right, questions from number 5. Does that say 2, 1 and 4, 1? Yeah, you're absolutely, I wrote this 2 different ways. So let me kind of box this one out. You're either going to see it as the coordinates 2, 1 and 4, 1 for the absolute minimums, because they're these 2 points here. Or sometimes you'll see it just give the y value. Remember that was kind of part of the note packet part, that it said you're really looking at what the y values are to figure out what a minimum would be, because you're thinking vertically what's the highest and what's the lowest. So yeah, one way to write it is that you've got absolute minimums at the coordinates 2, 1 and 4, 1. Kind of the same thing you did over here with your maximum. We use the coordinate to say where that was. It's sometimes the safest way to do it, because really the answer is the minimums at 1. This one would be the maximums at 2.09. But it's kind of safe to just say at what x value it would be. Kind of makes a little bit more sense than just using the y value for that. So I would probably use the coordinates, Scotty, when I'm writing that. All right, last one. One to go. We can do it. These are long periods, aren't they? Yep. Talking to myself. Okay. I want to do number 7, but I actually want you to do number 7, but I'm going to start you off on it. So here we go. We are going to look at x squared minus 1 over the square root of x squared minus 9. And I want you to go back to Desmos, and I want you to see if you can graph that. I will share my screen and show you. I'll give you a minute, though, to plug yours in. Again, to find those square roots and such, it's down in the keypad, which you probably knew that anyway. All right, once you have it plugged in, let's talk about some key parts to this graph so we can put it on our paper. Do you have any vertical asymptotes? And you kind of, Desmos doesn't show them to you, but if you go over to the equation and you think about it, what's going to cause a zero denominator for this? And if you have x squared minus 9, then if x is 3 or negative 3, that's going to cause a zero denominator. So you actually have two vertical asymptotes. One's at x equals 3, one's at x equals negative 3. And if you look at the picture, you kind of can tell that that's true. So the first thing you want to draw on your picture are your two asymptotes. So one's at negative 3 and one's at positive 3. Now from there, you've got these funky little swirls that come down and go back up again. And it's going to be important for me to know about where this coordinate is, right? Where is that low point? Where is that going to hit? And so you kind of just trace on it a little bit, and thankfully Desmos does that for you. You end up with this coordinate, negative 4.123 and 5.657. Let's just go, for the sake of where we're at, let's just take it to like 1 or 2 decimal places. So I know I have a coordinate at negative 4.123, 5.657. Toss that on your picture. So go negative 4.1-ish and 5.6-ish. Toss that coordinate on your picture and put the coordinate off to the side. So negative 4.1 and 5.7, we'll say. And then go to the one on the right and do the same thing. And you can see because of symmetry, it's actually exactly the same coordinates, just they're both positive now. All right, so put that one on your picture. And label it. And then sketch your graph. So get all the key information off of the Desmos picture before you go back and try to do your problem. So I'm going to stop that share, take you back to my notes. All right, so here's what you should have so far. You've got your asymptotes we talked about. You've got those key points labeled and the graph given to you. All right, I'm going to give you a couple minutes. I want you to tell me what the domain, absolute max and min, local max and min, increasing, decreasing, left and right end behaviors. I'll let you fill in number 7. When you are finished, give me a done in the chat so I know when I should go over it. All right. As you're finishing up, let's see if we match. All right, so first thing you've got is domain. It has a blank space in the middle of this whole thing. So it goes negative infinity to negative 3, and then picks up again on the other side of 3 to infinity. Doesn't touch the 3 or negative 3 because they're asymptotes. And then you have an absolute lowest point overall. That lowest point is at the y value of 5.657. Now, however you wrote that, you could write that a couple different ways. You could just list the 2 coordinates as your absolute minimums. But really, it's the y value you're looking at. There are no local maximums or minimums. Remember that the absolute is really relative, is really the local as well. So if it's an absolute, it really beats out the local stuff. So there is nothing else in the picture that's going to be in its neighborhood a little hill or valley. Increasing from negative 4.1 to negative 3, from positive 4.1 to infinity, decreasing from negative infinity to negative 4.1, and from 3 to 4.1. On the left it goes to infinity, and on the right it goes to infinity. And that takes care of number 7. So questions on 7. Yeah, the end behaviors is where, if I were to trace this far to the left, if I keep going left, 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 what's it doing? And the numbers are getting bigger, 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 right? If I keep going left, trace it left, my numbers are getting increasingly bigger. So it's going towards infinity. If I trace this thing to the right, again, the end behavior at the very end, what's it doing when I go right, 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 right? It's going to positive infinity. That's your deal.
Pardon the interruption. Just a reminder to please wipe down your desk and area before leaving class. Once again, a reminder to please wipe down your desk and area before leaving class. Thank you.
Okay. So the other thing you could do is if you go back to your Desmos equation and get the table and put in a really small number. Remember we did that with negative 1, 0, 0, 0, 0 to see what it's doing, and put in a positive 1, 0, 0, 0, 0. See what it's doing when you put in a really small number and a really big number. That would be another way to check the end behaviors, but really you're just tracing the graph. All right, other questions from 7 or anything else from today? Let me take you back. Don't leave yet. Hold on. Let me take you back to what we're up to here. So we did the whole notes on section 3.2. That's the whole, there was nothing more to say. You have practice problems 1 through 7. We did 3 of them. That leaves you only 4 to do. My question for you is, when do you want that due? It has to be due before we meet again on Tuesday, because we're going to go over it on Tuesday. So you tell me. Give me a deadline. Ain't nobody telling me nothing. Sunday, okay. Anybody else have a suggestion? Okay. Again, I'm taking this from your survey. You wanted to have some input on when due dates were, so that's what I'm trying to give you. Give you the input there. All right, so we're saying it looks like Sunday's good. Okay, so Sunday it is. I'll put that in for Sunday. Do Sunday. And then Monday you're going to watch the 3.3 video and take notes on that, so that when we say, I'd say Monday, but then I won't do it. Yeah. Procrastination, right? That's one of the problems with this doing your own remote schedule is, yeah, it's easy to procrastinate sometimes. All right, so this will be due for Sunday. Monday you are watching the video on 3.3 and taking notes on that, and when we meet again on Tuesday, we're going to start that section on piecewise functions, section 3.3, which, by the way, is the last section in this unit. So when we get finished this, we're going to spend a few days on 3.3, and then we'll do the review again and the whole 9, but you will have a test coming in the near future. Okay, just so you can keep that on your radar. It'd be Sunday midnight, yeah. Sunday midnight's fine. Yeah, you're good. Okay, questions for me? Anything else? Have a fabulous weekend.